Right, so number 2, the maximum range. Are we ready, everyone? Guys? Starting now. In number 2, the maximum range is 35 kilometers. So what you need to picture here, you have a point, and it's a telephone mast, telephone pole, and the range is 35 kilometers. So that's how far the signal can go. Okay. Now, you pick up the signal on your phone, and so you assume that you've walked just in range. And then what happens is you walk for 42, or you travel for 42 kilometers, and then the signal is lost. Okay? So you're traveling along, and then you pick up a phone signal, and you have the phone signal, but then you lose the phone signal. And I say in the question that this is 42 kilometers. So my question is, what is the closest you ever get to the telephone mast? In other words, what is this distance here? That's what I'm looking for. Yep.
What's 42?
That's how far you travel. That's how long you're in range for. It says in the question, I think it says you travel 42 kilometers and then the signal is lost. Yeah. So we want to find this distance here. Now, you might want to say that this here splits this into 2 equal pieces. And it does, I think it does. But we've never done any results in trigonometry that makes us know that for certain. So we'll just do this using the rules we have, which is the sine rule, the cosine rule, and Pythagoras. First thing I'll do is I'll draw a hypotenuse here, and I do know how big this hypotenuse is. How big is this? 35. And I want to find this x here. And I do know how big this one is here. 35 as well. So because I have 3 sides here, I could use the cosine rule. I'll use the cosine rule to get this angle here. I'll just call it A. Angle A. So the cosine rule says that, now when I say 35 squared, I'm looking at this side opposite the A. 35 squared equals 35 squared plus 42 squared minus twice 35 42 cos A. So I get 35, well, those 35s actually cancel. So I'll end up with 42 squared equals, that would be 70 at least by 42 cos A. So I'll take those down. So has somebody typed that in? 42 squared over 70 times, oh, well actually that cancels into that. So what's 42 over 70? That's my cos A.
That's
0.6. 0.6 exactly? Yeah. That's my cos A. Now, we can find the angle. So can someone tell me then what the angle is here? 53.1 degrees. Okay, now, somebody tell me what sine A for this triangle is. I mean, from the triangle. It's opposite over hypotenuse. So what would the sine A here be? It'd be x over 35. So we have our answer. Therefore, x equals 35 sine A, which we just worked out on our calculators. So sine, the answer on the calculator, multiplied by 35, and what do we get? 27.9. So we'll just round it to 28. 28 kilometers. Okay, and that's the answer then. So now it doesn't quite look as difficult as you thought. Huh? Yes. Well, that's the difficulty with these questions. Not so difficult now, right? If you had, normally they do. Yes. So if you had a picture, it would help you. Will the picture help you? I hope, but I don't know. You should get a diagram with these questions. I think if you have a look at the past papers, I think every time they give you a diagram. But there's no rule in the syllabus that says you will get a diagram. So, I mean, it's possible that you won't. In the past, they have. Okay. In this example, yeah, range would mean radius in this context, yeah. Okay, so like I said, I'll leave the other questions for the tutorial, but everybody, I would hope, should be able to do number 3 and number 4 because they're like the example I did in class. But number 5 is a bit tricky. Number 6 you might be able to do now because you can kind of compare it to the example I just did. It's a more difficult, but it's a similar type of problem. Okay, so we'll go on to the next topic now. So now we're going to have a look at trigonometric equations. These, good and bad news is, bad news, they can be quite long, but the good news is they're pretty much the same, well, no, they are the same process each time, okay? So although it's long, it is the same steps each time. So when you do a couple of them, you get the idea what you need to do. And these trigonometric equations come in 2 forms. The first one is what I'm going to do as an example, is linear. And then the second one is like a quadratic form. So we'll just take number 1 here as our first example. How do we go about solving something like this? Minus 5 sine 2x plus 5 degrees minus 3 equals 0. Now, first thing to check is what unit are we using here? Degrees. So before we start the question, and you'll definitely need your calculator for this, so put your calculator in degree mode. And you're also told that x is between 0 and 360 degrees. So, if we get any answer that is not between 0 and 360 degrees, we reject it. This 0 to 360 degrees is one full circle, right? And when that happens, when you have one full circle, there is a very convenient way to work out how many answers you should have. This is what you do. You take the number in front of the x and you double it. So for this question, we are expecting 4 answers. 4 answers. Okay? So we should have 4 answers for this. Now, just before I start doing that, I just want to go to the side and just clear up some things on your calculator, okay? If I type in something like sine, let's say, 10 degrees, can you tell me what that is, please? And at the same time, I'll open up my program here. So what is sine 10 degrees? 0.17. Now, what is sine inverse 0.17? It should be, yeah, it should be about 10 degrees. About, okay? So, when you look at this equation, sine x equals 0.17, you might think to yourself, okay, easy, got it finished, x is 10 degrees. And that's true, but these always have pairs for answers. Your calculator only gives you the first answer. So for example, if I wrote x squared equals 9, what would x be? Plus or minus 3. But what does your calculator say when you do square root 9? It's just 3. So you know you need to add in plus or minus, right? Same deal here for sine equations, cosine and tangent. The answers go in pairs. So I'll give you a little table that will help you to find the second answer. Okay? So what I'll do now is I'll go to the other side. So for sine, when you get your first answer on your calculator, the way you get the second answer is you just do 180 minus the calculator answer. That gives you the other answer. So let's try it for this. 180 minus 10 degrees, what's that? 170. Now type in sine 170, and do you get 0.17 roughly? You do. Okay. Oh, and I should say, this is not in the formula book, these three here. Cosine, the second answer is 360 degrees minus what you get on your calculator. And then finally for tangent, no, actually 180 plus what you get on the calculator. Remember these, not in the formula book, you will need them in semester 1 and semester 2. Okay, can I go back now? Yep. Alright. So when you're solving this, there's steps to solving it. The first thing you should always do is get it ready for your calculator. In other words, get it ready so you can calculate the inverse. So what I would need to do here is bring the 3 to the right and divide by minus 5, and I would get minus 0.6. That's right, isn't it? 3 and then divide by 5. 3 over 5 is 0.6, isn't it? Yeah. Now, can you tell me on your calculator then, what is sine inverse of that minus 0.6? Sorry, say that again, Joshua. Give me 2 decimal places. Minus 36.87 degrees. It's minus, isn't it? Yeah. No, yeah, it's minus, yeah. And Joshua, you did type in minus here and you got a minus answer. That's fine. Now remember, I just said a moment ago, you have 2 answers here from your calculator, really. So if we do 180 minus minus 36.87, what do we get? 216.87 degrees. So that is the first step done. The second step is we need to check if we have enough answers. How many answers did I say I should have? 4. And how many do I have here?
2.
Only 2.
Technically 1 because it's 0 to 316.
Yeah, well, we won't worry about the range until the end, yeah. Oh, no. Come back for the second class. Come on back for the second class. Now, hey, what's saying? There are only 2 answers here, but I said there should be 4. So what we need to do is make 2 more answers. And the way to make 2 more answers is very, very easy. What you do is you take the 2 answers that you have and add 360 degrees to them. And it's always 360 because what you're doing is you're going around the circle once to make another angle. And if I needed two more answers again, I would add 360 again. So keep adding 360 to make as many as you need. What's wrong? Just add 360 to each of these. So what are the two angles here, please?
It's 2x plus 5 is that much. So
Oh yeah, well we won't worry about that yet. I just want 360 added to these.
The first one is
Yeah.
323.13.
323.13.
The second one is
Yeah.
576.87.
576.87.
So roughly,
Yeah.
how do you know that we need four numbers?
There's a trick. You look at the number in front of the x and you double it. Yeah. Now, if you think about it, there's only really one answer I got on my calculator. This one here. All the other answers I have to make myself. This one here, I have to use this table. And then those two, I have to add 360. Okay. So I'll scroll down a bit. So now I have 2x plus 5 degrees equals minus 36.87 or 216.87 degrees or 323.13 degrees. I ran out of space. Or 576.87 degrees. Now you realize, well, yes?
What's the reason for having four answers?
What's that?
The reason for having four answers.
The reason or
Why we have four answers? Why are we actually?
well, what I'm going to do is at the end I'll draw a graph and I'll show you the four answers on the graph.
You said something about double equal.
I said something twice about that, so I can say it a third time. The number of answers is double what's in front of the x. Anyone need me to say it a fourth time? No? I could, or I could say it 3 times. Now, and the video's I need to find x here. So what I need to do with all of these is minus 5 and then divide by 2. So first one, x equals, so minus 5 and then divide by 2. So tell me what you get. While I'm plugging this in, why don't you work out each one? Minus 5 and divide by 2. Okay, so let's go through these. What's the first one then?
Minus 20.9.
Minus 20.9 degrees. 105.94, we'll just say.
Then 159.065.
07 or 285.94 degrees. Now, there's only one step left. I go back and I remind myself what x must be between. It must be between 0 and 360. So, this one, and this one we keep. But this one we might think we should reject. But there is a way to fix this so that we may not need to reject it. Whenever you have a negative angle, the way you can fix it is by adding 360. So I can fix this angle by adding 360 to it. And so what do I get? 339.1 degrees. Or 105 159.94 degrees, or 159.07 degrees, or 285.94 degrees. There are the four answers. So write them down, and then I'll draw the graph for this in a moment. Yeah.
In this case, an x is like every number is not x's number.
Yes. Did you write that down? Yeah. I'll draw the graph for this, although I don't know if I can get it in degrees. I'll try. So we have minus 5 sine 2x degrees plus 5 degrees minus 3. And I want to know when this equals 0. So if I graph this, hopefully it'll work. I should zoom out.
2 degrees. It's 2x plus 5 degrees.
I did write in 5 degrees, didn't I?
2 degrees, 2x degrees plus 5.
Oh yeah, well it is. It should really be for the program. I need to make it clear that everything's degree. Okay. Right, and then zoom in a bit this way. Oops. There we go. So there's let me set the range. So if I do range and it's from 0 horizontal to 360, and then I'll go minus 20 to 20. Okay. So there's 0 degrees, there's 360. How many times is across the x-axis? 4 times. Roughly about 100 degrees, about 150, about, I don't know, 280, about 340. I don't even remember what answers I got. Let's see. So what's the smallest answer at the bottom there? 105.4 degrees, which is that one there. Okay. So this is the reason as well. You can see it in the graph that if you graph it, it crosses 4 times. But of course you realise that if I was to zoom out, it crosses much more than 4. That's why in the question it should say 0 to 360. Okay? But sometimes it might say minus 180 to 180. So then you would expect 2 negative answers and 2 positive answers then. Something like that. Now, just a little reminder here of the order. Okay. So the first thing I did was here to here, I got it ready to calculate the inverse. So I call that I. And then you see here to here, that's where I make all the extra answers. Then here to here, that's when I simplify to find x. And then finally, the last thing I did was to fix any bad angles. Yes?
If the x was more than 360.
Then minus 360 then, yeah. So you can keep adding or subtracting 360 at the end until it fixes it. And if it doesn't fix it, then you reject it. There are some situations where that will happen, Ali, where even though you add or subtract 360, it wouldn't fit into the answer, the possibilities. Very, very rare, though. Very rare. No, it could be, yeah. It could be. You might think to yourself, is the order that important? For example, if I simplify first and then get the extra answers, will I get the same result at the end? And you don't. You don't. So this order is actually very important. So, I don't know, some of the students ask for a way to remember the order. So you can think of some sentence to try and remember IESF. I think we came up with, I eat sausages on Friday. Yeah. If you think of something better, let me know. But you need to remember the order. Inverse, extra answers, simplify the x, fix the angles. Okay? The order is vital. You get the order wrong, you get the answer wrong. Okay? So the order must be remembered. What's wrong? Simplify. So find the x. Simplify the x. Or I should really say simplify to the x. The which? Fix. Fix any angles.
You can fix them.
By adding or subtracting 360.
So just do this.
Just 360, no other choices available. Yep. Yes, it could be. If after simplifying you got 4 perfect answers, yes. Could be. And in fact, of course, as well, sometimes you might not even need the s if it's just an x already inside it. Yeah, sometimes these steps you almost skip over because they're already done. Yeah. Yes? No? I'm going to do the quadratic type next, okay? So write this down, and then I'll do 2c.
So see, and step 5.
Yeah.
Why did you take the inverse of 0.6 and it's not inverse? Like it was first with 2x plus 5 and then.
I need to make it so I can use on my calculator sine angle equals number. So in other words, I don't want the 5 and the 3 here, so I can't do anything with my calculator then.
Yeah.
To use your calculator, you need to have it like this: sine angle equals number. Then you can use the inverse button on the calculator. Yeah, there is a way to check your answers. If you take these four answers here and put them back into the equation, it should give you out 0 each time. And that is important because you can check the answers in the exam. Yeah. So you can try it. If you put in, for example, 105.94, 2 times 105.94 plus 5, sine of that times minus 5 and then minus 3, the total should be 0. Or graph it as well will do, yeah. 0 or nearly 0?
Minus 0.7.
Let's see. Is it minus 5? It's plus 5. You typed in minus.
The question says minus.
Question says plus. Yeah. There you go. Okay, I'm going to do 2c now. So we have 49 sine squared 3x plus 75 degrees. No, sorry, I'm mixing it up. 49 sine squared 3x plus pi over 36 plus 70 cos 3x plus pi over 36 also. Minus 74 equals 0. And we're told that x should be between 0 and 2 pi. Now, before I start this even, there's a problem. I can see that I have a sine and a cos, and it doesn't work if they're different. I need to make them both sines or both cosines. Which one would I need to change? Does anybody know? The sine or the cos? I should change the sine squared because I have this formula. Sine squared plus cos squared equals 1. So that means sine squared equals 1 minus cos squared. Now, if you didn't know that formula, that's okay. It's in the formula book. It's one of the few formulas that we have in trigonometry semester 1. And the proof of it uses Pythagoras. So in fact, this is really Pythagoras but in a different form. If I draw a right angle triangle with hypotenuse 1, this side here will actually be cos A, and this side here will be sine A. So from Pythagoras you get cos squared plus sine squared equals 1. That's where it comes from. Okay, so just to save space, I'll write this as 49 sine squared plus 70 cos minus 74 equals 0. So I have 49 1 minus cos squared plus 70 cos minus 74 equals 0. So I get minus 49 cos squared plus 70 cos, and then minus 74 plus 49, which is what, 25? Minus 25, is it? Equals 0. What do we get here? Minus 25. So if I change the signs, 49 cos squared minus 70 cos plus 25 equals 0. Well, this is just a quadratic equation, isn't it? So you can use your calculator or use the formula if you like. A equals 49, B equals minus 70, C equals 25. So if I just use the formula,
It's not minus 3,
I multiplied everything by minus 1 as well. Mode, okay, so you get cos equals 5 over 7, or, oh, and that's it actually. The other answer will be 5 over 7 as well. So, nicely, we only have one possibility to look at. Normally, though, we could have two. It's just the second answer here is the same as the first answer. Now, let's write out what cos was. If you remember, it was cos 3x plus pi, wasn't it? Yeah, pi over 36 equals 5 over 7. Degrees or radians? Which? Degrees or radians? Degrees, yeah. So if I... no, radians.
No, it's
Radians. So I'm putting in radian mode. Now, if you look here, the I step is already done for us. Already done. So if I do cos inverse 5 over 7. Oh, by the way, how many answers should I get here? 6. So the first one is 0.775. What's wrong? I can try and go back a bit. The first one is 0.775. How do I find the second answer for cos? 360 minus the first answer. But if it's radians, 2 pi minus the first answer. So that would be 5.508. Now, how many more answers do I need? Yeah, I need 4 more answers, don't I? So 0.775 plus 2 pi, and I get 7.058, and then 5.508 plus 2 pi, and I get 11.79. Then I add 2 pi onto these two to make 2 more answers. 7.508 plus 2 pi, 13.791, and then finally 11.79 plus 2 pi, 18.073. So that's the E step done. Now I'm on to the S step. Yeah? Oh, hang on, sorry. Yeah. What I did was, just to be clear, this one here I got from my calculator. This one here I did 2 pi minus that one.
In the first,
Yeah.
first equation we minus by 180, which is
No, that was because it was a sine. This one's a cosine now. So if you look at the table, I think I said 360, didn't I? Do you have the table still? Did you write down? You know what a table I'm talking about, don't you? Got it now? Yeah. And then I always add 360 or 2 pi to make those extra 4 answers. Okay. Now, next is the simplifying to x. So what I need to do is minus pi over 36 and then divide by 3. So I get x equals minus pi over 36 and then divided by 3. Okay. 0.775 minus fraction pi over 36 and then divide that by 3. Okay, so my first answer is 0.229. Then my second one, 5.508, is 1.807. Then my next answer, 7.058. That is 2.323. And then my next answer, 11.79. 11.79. That is 3.9. 2 more to go. 13.791. 4.568. And then lastly, 18.073. $5.995. So we'll just say 6. Now, I've done my I, I've done my E, I've done my S. Do I need to fix any of these? No, I'm finished. It's because it is 0 to 2 pi, isn't it? Yeah, so if I look here now, 2C, 0 point, yeah, there's a bit of rounding off problems here. I didn't take enough decimal places. The first answer is 236 and I got 229. And then the last answer, 5.995. I rounded off to 6. Okay. So this one here, I was a little bit careless with that. The next one, 1.806. Yeah, close enough. Next one, 2.33. Close enough. They're fine. I think my problem was this. I should have, for the exam, for your calculation, how many significant figures should you do? No, that's for the answer. The calculations should be 4. So how many do I have here? I only have 3, don't I? So that's why there's quite a big difference for this. I should have done an extra number here, but it doesn't matter. I'm not worried about that right now. Yeah.
How do you check if it's between 0 and 2 pi?
What do you mean? Say that again. How do I?
You identify that it's between 0 and 2 pi.
Yeah. So 2 pi is 6.28. All these answers are between 0 and 6.28. There's nothing to fix. They're all fine. Now, I had 6 answers here. But do you remember when I solved my quadratic, how many answers did I get from my quadratic?
2. 1.
Well, only 1 really, because the 2 were the same, weren't they? So if they were different, how many answers should I have at the end here? What do you think?
Twice this.
Twice this, so in total 12. Okay? So that's what I mean. These questions can be quite big and quite long. But the good news is they will look like this in the exam. You know, you can't really make it any different. And the steps are the same, IESF. For the quadratic, there's just 2 extra steps. Make it into a quadratic and use the formula. Okay. But basically these quadratics, they're just like two linear problems inside of it. Do you understand what I'm saying by that? Yeah. So it's really important that you practice these of each type. So I'll let you work on these for a few minutes. I think it'd be nice if you could do sine, cos and tan from number 1. So let's see if I look towards the end. Yeah. PQR is a sine, cos, tan. PQR. Let me mark that. So we have PQR, and then likewise I'd like you to do sine, cos and tan in number 2.
CD.
I just did C, so we won't give you that one. D. D and E. Yeah, actually, you just do D and E, that's okay. Alright, so you have 5 questions there, and you might get them done now. Okay? So if you work on those now.
What's the application for this? What's the application for this? Like where in real life do you, or anywhere do you see this?
Let me just stop this for 1 second. Well,